So today is a very monumental day in your calculus career. Today you're going to learn the chain rule. The chain rule is its official calculus name. And so what we're going to be doing is we're going to be taking the derivative of a function within a function. So this is a composite function. Like you take G and plug it into F. So like if I look at number 1, the inside is the 3x plus 2. But the outer function is the x to the 5th, or the something to the 5th. It can have as much as, I call them layers, it can have as much as 3 different layers, especially when you get into functions that have ofs, like trig, sine of something. So if you have sine of 2x, sine is the outer function, 2x is the inner function. And then I can square that. Now I have 3 layers. The square is the outer function, the trig is the middle function, and the of is the inner function, the inside function. So you can think of it like layers, like an onion, and you got to peel them back. But what it makes me think about, and I have no idea because I've never had one of these, but it makes me think of a turducken. Now, if you are a vegetarian, you may want to, on principal beliefs, then you may need to not watch this little video that I'm going to show you. But I am going to refer to these as turduckens, and we're going to talk about what the turkey is and what the duck is and what the chicken is. Now, for those of you who don't know what a turducken is, a turducken is a turkey, a duck, and a chicken. So it's the turkey is the outer part, turduck. Then the duck is the middle, and then inside of that is the chicken. So it's a chicken stuffed inside a duck that's stuffed inside a turkey. It's a real thing. People make it. I've heard they are fabulous. So just for fun, let's watch this. Let's begin by preheating the oven to 375 degrees. This recipe calls for a 3-pound bone chicken, a 4-pound bone duck, and a 16-pound bone turkey. You can bone out the birds yourself, or ask your butcher to do it for you. Season each of the birds liberally on both sides with salt, ground black pepper, and Creole seasoning. Next, you'll need 3 cups of prepared and cold stuffing. Feel free to use more if you like. We're using Stephanie's sausage and oyster stuffing recipe from our site. Now lay the turkey upside down and spread the stuffing in an even layer. So that's the turkey. Next, lay the duck upside down on top of the turkey and spread with more stuffing. And lastly, place the chicken upside down on top of the duck and spread with the remaining stuffing. Here's the fun part. Bring the edges of the turkey skin up and fasten them together with toothpicks and skewers. Using kitchen twine, lace around the toothpicks and skewers to help hold the turducken together. Carefully place the turducken breast side up in a large roasting pan and cover with foil. Roast in the preheated oven for 4 hours. Taste the turducken every hour with its drippings. The finished turducken should be a nice golden brown color. The thigh should register at 180 degrees and the stuffing at 165 degrees. Let it rest for 15 minutes before carving. So you guys see all those inner layers. This recipe for turducken will be a hit at your next Thanksgiving celebration, and just so you have your family's annual tradition. All right. So I want you to think of these as the turkey as the outer shell, the duck as the middle layer, and the chicken as the very, very inside. Not all functions are a full turducken. Some of them are just a turduck. If it's just a turkey, then you know how to handle it. Like you know all those rules that can handle that. But if it has something inside, an inner function, then it's at least a turduck. So if I were to look at number 1, you can't power rule that sucker. And I definitely don't want to write it 5 times. So what I'm going to do is I'm going to look at this as the power on the outside is the turkey, the outer shell. The 3x plus 2 is the inner part. That's going to be the duck. Okay. So to do this, I take the derivative of the outer part. So the derivative of the turkey. I leave the inside in the turkey. Then after I do that, I take the derivative of the turkey. Of the duck. So derivative of the turkey, leave the duck alone. Then derivative of the duck. So y prime. I'm doing the outer shell first. So I'm doing the power rule. My power rule is my turkey. So 5, 3x plus 2 to the 4th. So I did the power rule on the outer shell. But now I have to take the derivative of the inner part. I have to do this part. I have to take the derivative of the duck. Well, the derivative of 3x plus 2 is a 3. So then y prime is 15, 3x plus 2 to the 4th. Now, I'm not going to, what I would normally do in class is say it multiple times because I'm not going to do that because I know that you can pause it, rewind it, and listen to it all again. Then anything that you're iffy about, I want you starring and writing questions out on the side so that when we come together as a class, you can ask me questions. Okay. All right. So number 2, again, the outer shell is the power, the 2, the square. So I'm going to do a power rule. And then I got to do the derivative of the inside. And then if I clean that up, I could leave it. I don't know why I switched those. Doesn't do any good. I could lobster that out. I could run a 2 through. It doesn't make sense to run a 2 through one of them because it could go through the other one also. So there are lots of things you could do to this. I think most of the time they're going to stop right there. But if it's multiple choice and they lobster it out and then run the 2 through it, then by all means. Okay, number 3. So number 3, when I look at this, I see the outer layer as the square root function. That's my turkey. The duck is the x cubed minus 4x. That's the inside part. So the outer part is the square root. The inside part is the x cubed minus 4x. Now, you guys know that that is the same thing as that. So I'm going power rule on the turkey. Leaving the duck. Now I'm doing derivative of the duck. Now I'm going to clean it up. We said no negative exponents. There you go. Outer shell, turkey, inside, duck. Okay, now let's see. You could look at this as a turducken. The turkey is the cube root. The duck is the square on the outside of the parentheses. and the chicken is the x squared minus 1. So you could look at him as 3 layers. I, however, am going to rewrite this, and I'm going to put the power over the root and force that to be 1 layer, because I don't want to do a turducken unless I have to. I'm all about a turduck. So then y prime, outer layer first, times the derivative of the inside. Now I'm going to clean. Okay, so that one had a little prep work. Okay, now let's dip our toes in some trig. Now, remember, that is not sine times 2x. That's sine of 2x. The of becomes the inside. What does it become the inside? It is the inside. It's always been the inside. So your outer layer is the trig, the sine. That's it. That's your turkey, the sine. The inside part is the of, the 2x. So you're going to do derivative of the trig, leave the of alone, then times the derivative of the of. So y prime, derivative of sine is cosine, leave the of. Because your first pass at it is just to take the derivative of the turkey, leave the duck. Then I need to multiply by the derivative of the inside. So you cannot multiply these two together. This is a free 2. This is not a free 2x. This is an of 2x. It's not available. So number 6, same thing. The tangent is your turkey, and the 2x squared plus 1 is your duck. Derivative of tangent is secant squared. So derivative of the outside, don't touch the duck, times derivative of the duck. Again, I'm not pausing because I know you can pause it. All right. So this one is almost the first turducken, but he's not. If he had an of, it would be a turducken, but he doesn't. This is the same thing as this. Or it's the same thing as this. It is not the same thing as that, because this right here is that right there. That 1/2 that's in red only applies to the of, and that's why it becomes number 8. Number 7 is the cosine is under the square root. So you can put that power on the cosine, or you can put the whole cosine and his of in parentheses and put the 1/2 on the outside. I'll tend to do the first one, but I have had students in the past that say this second way helps them see the tur and the duck. Okay, so whatever floats your boat. So my outer layer is the power, my inner layer is the trig. Outer layer is the power. So 1/2, don't touch. Oh, hold on. Take 1 off my power. There we go. So that's the outer layer. Now I have to times the derivative of the underneath, the inner part. So negative sine x. And again, remember, I have people in the past who have always written this like this. And if you do this, then you can see, okay, I bring the 1/2 down front, take 1 off my power, and then the cosine is your inside layer. So then I do the derivative of the cosine. So whatever floats your boat. So I'm going to have a negative sign on top and a 2 and a root cosine on the bottom, or you could make it cosine to the 1/2 x. That's fine too, either way. Now number 8, the outer layer is the trig, the cosine. The inner layer is the of the x to the 1/2. So this, if you really wanted to spell it out, is that. So y prime, all right, outer layer is the trig, so trig first. Don't touch the inside, then times the derivative of the inside. There you go. Okay, outer layer is the trig, inner layer is the of. The of is the 3x squared. Outer layer is the trig, the cosine. Inner layer is the of. So the turkey is the cosine. The of is the duck. So turkey first. So trig first. Don't touch the duck. Times the derivative of the duck. There you go. Now, notice I have 9, 10, and 11 all here beside each other so you can see the difference. Just because you see trig and just because you see ofs and just because you see squares, I don't want you to think trig is always the turkey, because that's not true. In number 10, trig is not the turkey. The outer shell here is the power, because that whole cosine is being raised to the second power. So your outer layer, your turkey, is your square. The inside part, the duck, is the cosine, the trig. So power first. Don't touch the trig. Times derivative of the trig. Ooh, that's one of those double angle formulas. There it is. So that's twice in like a week that sucker's popped up. Okay, number 11. All right, now think through number 11. Think through, what do you think is the turkey? What is the duck? We haven't done a chicken yet. So this is cosine of x squared. So the outer layer is your trig, and the inner layer is your x squared. So trig first. Don't touch the duck. Times derivative of the duck. Okay, number 12. Now before you knew the chain rule, your only option would be take that x minus 1, write it 3 times. Lobster all that crap together. Then take that answer and lobster it with the x squared plus 1. But now you know the chain rule. Now, I hope you guys can see that this part right here is going to need the chain rule. But that's going to be a chain rule within a product rule, because I have x squared plus 1, which is not a chain rule, times 1 minus x cubed, which is a chain rule. But the fact that these two suckers are being multiplied together makes this a product rule. So the overlying rule is product, but when I do the derivative of the dude highlighted, it's a chain rule. Okay, so here I go. leave it, derivative. Okay, derivative of what's highlighted is chain rule. Outer function, the turkey, is the power. The duck is the inside. There's your derivative. So this was leave it, derivative, and this derivative was a chain rule. Plus derivative, not a chain rule, just regular derivative, leave it. Okay, now we got some stuff we got to clean up. This is some really fun algebra. And I'm only sort of being sarcastic. Okay, I see some singles. I see the 3 and the -1. Okay, so I'm just going to clean those up. And I see kind of this big fat island and that big fat island. So I'm going to clean up island number 1. So -3 x squared plus 1 times 1 minus x squared plus 2x times 1 minus x cubed. Okay, again, I still see 2 large islands. I see that they both have some of those. So I'm going to GCF the smallest power out. So I'm going to GCF a 1 minus x squared. Okay. So when I take this out of the first island, it completely takes that guy out. And I have -3 parentheses x squared plus 1. And yes, I'm going to distribute that -3 in just a second. If I take a 1 minus x squared out of the second island, I'm going to have a 2x, and I'm still going to have one of those 1 minus x's. So now I'm going to distribute, and I'm going to do it up here. And now I'm going to clean it up. So -5x squared plus 2x minus 3, because I'm OCD and it has to go in order. Now, nobody's asking you to write the 1 minus x twice and lobster it out and then lobster that with what's inside the bracket. That's not the point. Number 1 is do your derivative correctly. And number 2, recognize that they have this green highlighted piece the same and that you can GCF that out and then clean up what you have left. That right there is going to happen a lot, especially with a product rule with a chain rule in it. Okay, number 13. Now I'm going to erase number 12 because I need room for number 13. That's going to bother me. Okay. All right, so here we go. So a little prep work. Okay, so guys, I see product rule with a chain inside. Okay, so here I go. Leave it. Derivative. Now the derivative of this second dude is a chain rule. Power on the outside. Leave the inside. Derivative of the inside. This is the duck part. There you go. Okay, so let me show you what I just did. I did leave it, derivative. So that's 1/2 of the product rule. Plus derivative, leave it. All right, now let's clean. All right, I'm cleaning up my singles. You're going to start to see the pattern. So he's single, and this is one big fat island, and there's an island. So y prime equals -2x cubed Oh, times the 1/2. I can do that too. Hold on. Let's do that one more time. Give me my green. He's single. Okay, so now negative x cubed. Much better. Times 1 minus x squared to the negative 1/2 plus 2x, 1 minus x squared to the 1/2. Okay, island number 1, island number 2. All right, I spy with my little eye an x that can come out. And I'll also see a 1 minus x squared. One of them's to the negative 1/2, one of them's to the positive 1/2. We are always going to take the smaller one out, which is the negative 1/2. Okay, that is what I'm GCFing out of both islands. So when I take this out of the first island, this is all I'm looking at. I have a negative, an x squared, and the 1 minus x squared to the negative 1/2 is completely gone. Plus. Second island, I have a 2. All right, when you GCF, that's division, and when you divide, you subtract your powers. So this is going to be 1/2 minus a negative 1/2, which is a 1. Okay, I'm going to stay right here and clean this up. Okay, now I have this dude staying on the top. These are like terms, negative 3x squared plus 2 over, how's that? Yep, looks good. I lost a square. There he is. I lost a square on him. I'm sorry. There we go. Yeah. All good. Okay. And I think on these problems, it's really good. I don't know, maybe just sit and watch it one time and then go back and watch it again while you write it down, or vice versa. Watch and write it down and then go back and just watch it. But I think it's very beneficial to have your eyes and ears on these problems twice so that you're not trying to keep up with the writing. And again, I hope you know that you can pause it anytime. But the watching it multiple times, I think, is very beneficial. Okay. I am going to prep him a little bit. Okay, I'm going to low D high this sucker. And my low, the D of my low is a chain rule. It's a turduck. It's a power on the outside and crap in the middle. So here I go. Low, D high, minus high. Okay, D low. D of the low is a power on the outside and then a power on the inside. So turkey, duck. I think brackets are a really good idea here. Over low, low. When you have a power to a power, you multiply, and that would be 1/3 squared, so that's a 2/3. Oh yeah, this is a good one. All right, I'm cleaning up all my singles. So this is just x squared plus 4 to the 1/3 minus. Okay, now let's clean up single, single, single. So 2/3 x squared. Oh my gosh, it's got a fraction within a fraction. Yep, That move is coming. Get ready. Okay. Eyes on the top. Eyes on the top. On the top, I see that they both have an x squared plus 4. One is to the 1/3, one is to the negative 2/3. We are going to GCF that out, and we always take the smaller number, and the smaller number between a 1/3 and a negative 2/3 is negative 2/3. So I hereby declare that we are going to GCF an x squared plus 4 to the negative 2/3 out of that island and that island. When you GCF, it's the same thing as division, and when you divide, you subtract your exponent. So this is going to be 1/3 minus a negative 2/3 plus, that's 3/3, which is 1. So I have x squared plus 4 to the 1. I'm not going to write that, though. Minus, my single stuff stays, and that whole back end is gone because it GCF'd it all out. Okay, now stop for a second and look at the magic that's about to happen. Okay, I see like terms inside my brackets. I see a fraction inside my bracket. I'm going to be multiplying everybody by 3 in just a minute. I see the thing on the outside that's to the negative power, so I know I'm going to move that down. So when you move this down, the power becomes positive. And when you multiply, you add your powers. And when you add your powers, 2/3 plus 2/3 is 4/3. Okay. In here, this is a 1, which is a 2/2. So, nope, a 3/3. Sorry, common denominator. 3/3. So that's going to give me 1/3 x squared plus 4. Oh, this problem is just amazing. So y prime equals, all right, now I'm going to multiply everybody by 3. So x squared plus 12 over 3 x squared plus 4 to the 4/3. Oh my goodness. That's amazing. Amazing. Let me check it, make sure I did it right. Yep. Yay. Dang. I mean, that's beautiful. Gorgeous. Gorgeous, gorgeous, gorgeous. The calculus and the algebra, it's all just very pretty. Okay. I'm getting kind of excited. Okay, number 15. All right, I see a fraction, so I'm thinking quotient. But outside of the fraction, I see a power. So what's captain of this ship, what's driving this problem is a power rule that has a quotient rule inside of it. So this is a Turduck with a very, very large duck. So the outer derivative is a power rule with a 5. And the duck is a quotient rule. Now, I left you quite a bit of room, and he's going to use it. I did this in 4 lines of work, but they are hefty if you're trying to gauge how to write. Okay? So, y prime. Okay. Turkey is the power with the 5. So bring the power down. Don't touch the duck. Turkey gets all the loving right here. Boom. Turkey. Done. Derivative of the turkey. Times. Okay, now hold on. We're about to go inside the turkey to the duck. And the duck on this problem is that, the fraction. So now I'm a quotient rule. So I'm going brackets. And I'm about to low D high this sucker. Low D high minus high D low over low low. Now on the last problem, it was a quotient rule that had a power inside the quotient rule. This one is a power with a quotient rule inside the power rule. So it's very important for you to establish which one is your turkey and which one is your duck. Layers. Okay, good times. I am going to let this guy marinate. Yep, I'm going to let him marinate. I am noticing that I can GCF some stuff out of here. However, it's to the 4th power. So, but I'm just mental note. Like I could GCF a 2 out of the top and an X out of the bottom. But it's still to the 4th power. I don't know. I'm just noticing that, okay? So just side note. Okay. Now I'm going in here. If I distribute my 2, that's 2x squared minus 20x. There's a shark. Here's a lobster. 4x squared minus 20x plus 16x minus 80. That's the lobster. Haven't touched the shark, which is 4x squared minus 4x minus 80. And now I'm going to run my shark through it. And now I'm going to clean my like terms. I'm going to combine it with him. So negative 2x squared minus 16x plus 80. I sure wish y'all were in this room with me, double checking my work for my careless mistakes. Let me see how I did. Square minus 16 plus 80. Okay, I seem to be good so far. Okay, and everything that I just did kind of up there in blue is saving me from writing the big hunk of beast thing 1,000 times. So I just saved us some steps. I mean, I can GCF a negative 2 out of the top of the purple. And that negative 2 could come way out front and times the 5 and give me a negative 10. I also see this, remember it's to the 4th, and this, yep, I can do something there too. Okay, so here I go. Now, whether or not they GCF that negative 2 out of the top of the purple, I don't know. But very possible. So I'm going to go ahead and do it. So I'm going to make this a negative 10. This is going to be a 2x plus 8 to the 4th because of him times, and I didn't really need brackets there. Remember we took a negative 2 out. So x squared plus 8x, sorry, minus 40 over, now remember, this is to the 4th power. So that means I have 6 of them. Whew. Now, if they wanted to, golly, if they wanted to, do you guys see a 2 in here? So what they could do, guys, is they could say, all right, this is 2x plus 4, but that's to the 4th power. So I can't do this 2 times this negative 10, but I can raise the 2 to the 4th power, 8, 16, and multiply that 16 times that 10. And if they wanted to, they could take an x out of here, as long as the whole thing stays to the 6, or they could do this. That would be fun too. I'm just trying to think of any way that they could mess with you on a multiple choice, because if they can, they will. I promise. I promise they'll do it. They are any problem that is just crunchy rules. On a multiple choice question, they're going to twist it. They're going to find some way to twist that knife just a little bit. And that's what makes it fun. And that's honestly, guys, that's what separates the 5 and the 4s from the 3s. The 4s and the 3s from the 2s. If you're going to get a 5 or a 4 on this calc test, you're going to earn it. And you're going to earn it by catching little stuff like that. Little algebra stuff. Okay, 16. Let's see. Turkey is the power, and the duck is the quotient. Ooh, and I'm looking ahead at number 17. Ladies and gentlemen, we have our first turducken. All right, so 16. Turkey is the cubed, the power. The duck is the quotient. So tell you what, pause it. Pause it and try 16 on your own. Then hit play and watch me walk through it. And see how close you can get. All right, 3. There's your turkey. Then low, D high minus high, D low over low, low. Oh yeah, this is a good one. Let's see. I'm going to go in here. This is just x minus 6 minus x. So that all goes to a negative 6, who is now single. And that single, not being raised to any power, is available to be multiplied by him and that x squared. The x minus 6 is also squared, so be careful there. So I'm thinking negative 18x squared is my numerator, and an x minus 6 to the 4th is my denominator. Great problem. Super, super. Okay, I'm excited. 17. Okay, your of is the innermost layer. Your power is your outermost layer. The trig is the middle. So the turkey is the cube. The duck is the cosine. And the chicken, it's your first chicken, is the 1 minus 4 theta. Now remember, theta is a variable. It's an x. Okay? So here I go. Now this one's gonna, it's not, it really doesn't take that many lines, but the line that you need is very long. Okay? So I'm gonna come over here. Okay. Power, trig, of. Those are my three layers. So power first. 3 cosine squared. There you go. There's your turkey. Okay. Then your next is the duck, which is the trig. Well, derivative of the trig is negative sine. Don't change the of. So this is turkey, duck, and now I'm going to take the derivative of the of, which will be a negative 4. And that is your chicken. Yay. Now we clean. Remember, if it's an of, it is not available to be multiplied by anything. So here are my singles. I have a 3, I see a negative 1, and I have a negative 4. So negative 12 cosine squared 1 minus 4 theta sine 1 minus 4 theta. Done. $18. Huh. This is a turducken in a turkey. So this right here, anytime you see a power on trig with an of other than x, that's a turducken, guaranteed. So that's a turducken, just what I've underlined right there. Sitting inside of a turduck. The outermost is the 4. That's the turkey. The duck is the 1 plus sine squared 3x. But the sine squared 3x is a turducken all by itself. Ooh, the layers. It's amazing. Okay. Outer. That's the power. 4. Don't touch. 3. Okay, so that's the outer part. Now I'm supposed to take the derivative of the inner. Okay, so times, well, derivative of 1 is 0. Now I get to the derivative of this mamma jamma, and that is a full-on turducken. So power, don't touch the trig, don't touch the of. Duck, chicken. Power, trig, of. Okay, singles. 4 of 2 is available, and the 3 is available. So y prime, 8 times 3 is 24. 1 plus sine squared of 3x cubed, sine of 3x, cosine of 3x. And if you want to keep those little ofs in parentheses, that is totally fine. Okay. 19. 19 is a full-on turducken. The turkey is the ln. But it's ln of the square root of x squared plus 2x minus 1. Well, the square root of x squared plus 2x minus 1 has 2 layers to it. So this is a turducken. The turkey is the ln, the duck is the square root, and the chicken is the x squared plus 2x minus 1. Okay, so 19. Okay, so in your mind, you should be thinking of this like that. Okay, so how do you take the derivative of an ln? Because that's my turkey. So ln is a log. I picture a log that has fallen over. It's in the woods, and what's sitting on top of the log? It's a bird. In particular, it's a dove. ln's are dove over of. Dove sits on the log. So if you have a log, it's a dove. So derivative of the of. Okay. Derivative of the of. Well, the of is a turduck. So 1/2 2x minus 1 to the negative 1/2 2x plus 2. Okay, that's my dove. Now over my of, which is there you go. Yeah. So the derivative of a log is dove over of. So I took the derivative of the of over the of. And the derivative of the dove, is my turduck. We got a lot of birds going on here. Your dove is your turduck. Derivative of the log is dove over of. Dove is the derivative of the of, so that's a turduck over the of. Okay, cool. Now I just got to clean it up. That's going down there, so that's going to make one of them. And I'm going to swing that to that dude down there. And then that, but then all those 2's can cancel. So it's x plus 1 over, and I don't need parentheses anymore. Oop. X squared plus 2x minus 1. There we go. Okay, I hope your brains are okay. We only have 2. Oof. We only have 2 left. Okay. So I see the outer shell as the root. Okay, I see that. The inner is a product rule. But I could lobster that. Like, that's just 2 terms times 2 terms. So I personally am going to lobster that. So, little prep work. When you multiply, you add your powers. 6x to the 6th minus 8x to the 5th minus 48x to the 4th. Okay, now it's just a square root, which is to the 1/2, and a very large duck. Okay, so here I go. Outer layer, bring the power down. Take 1 from your power. Times the derivative of the duck. Oh, 48 times 4. 192. Okay. Now I'm just going to clean. I mean, this is more annoying just to write it all out than difficult. There you go. That wasn't bad. Okay. 1 left. Boom. All right. I'm seeing a power rule. Yeah. No, I'm sorry. I'm seeing a product rule. Sorry, they both start with a P. I see the product rule. I see a log that's being squared. So the outer layer is not the log. The outer layer is the square. Then I have the log. Okay. So product, and then I have a log. Oh, no, I have power that has a log. Okay, product rule. Leave it. Okay, this is the fun part. So I'm taking the derivative of this. And again, the log is not the driving force. The outer layer is the power. So 2 ln to the 1 x plus 1. So there's the outer part. Then the inner part is the derivative of the log, which is dov over of. Derivative of the of is 1 over the of. Okay. So there's the leave it derivative plus derivative leave it. Yeah, I like it. Okay, 1 big fat island, 1 big fat island. Okay, this x plus 1 is a part of that ln, so he's being of'd. He is not, and he is not. Those can cancel. So I have 2 ln of x plus 1 plus ln squared x plus 1. Technically, you're done. But multiple choice with logs, guys, they're going to use those properties of logs all the time. So look at what you've got. Remember, numbers that are kicked out front are powers on the log. So this becomes, remember, the numbers that are kicked out front are not powers on your of, they are powers on your log. Yes. Hold on. Log of x cubed. No, that would be 3 log x. Okay, no. No, then you can't do this. Well, you could. Okay, so I'm sorry. But it becomes a power on your of. Powers on your of get kicked out front. It doesn't, but I wanted it to look like this, and that's not the case. Numbers that are kicked out front are powers of your of. So then I can do this. I was trying to force those two to be the same, but they're very much not. So they could do that if they wanted to. So if you're like, where the heck did they get an x plus 1 squared, and where did my 2 go? Well, numbers that are up front are powers for your of. So that's what they could do with that one, just to mess with you. Okay, so I hope you took your time through these notes and watched multiple problems multiple times. And we will practice these in class.